Hello everyone. I'm back. Okay, well, I'm back. You guys probably just saw this video right after the other one, so I'm just gonna continue with the Pompeii solve, and we are probably going to reset it and get the logic behind it to make sure that our logic is solid. Anyways, let's go. Okay, we are going to restart. So the four, okay, so for 2 by 2 area, again, we know this is all this is all valid. In the 2 by 2 area, there has to be one that is unshaded. So therefore, these are both, sorry, they have a value, I should say. So one of these has to have a value, one of these has to have a value. Same with box 4, right? So that means these cannot have a value, and this must have a value. Both of these must have a value. Both of these must have a value. Both of these must have a value. Only one of these can have a value. Only one of these can have a value. Could it have a value here? I don't think so, right? Oh, this has to have a value, and it's only one. It cannot be both, right? So one of these has a value, the other one does not. Because if they all had values, then this would be a 2 by 2 area that has values. All that is all the same shading. This is 1 and 1 also. This is 2. So only one of these has value. This has at least 2 value here. So again, we try to have... So this cannot have value here, because if it did, it would... there would be too many digits in this box that would have values. So again, we have to have the digits 0 through 9 here. Whatever digit is here matches here. We have to have 1 here. We have to have 1 here. So this is guaranteed 1 here, because it must have a value of 1, and only one of these could have a value. So this has to have 1. Why couldn't this be 1 here? I don't remember. Oh, it's probably because of that. Yeah. Okay, so where is the 1 here? There's 1 that has value here. Again, if we try to swap it, so if we try to swap it anywhere here, so this is basically... So we're taking a look at what happens if we swap anywhere here. So if we swap anywhere here, this would all have to be blue, right? Let's just go to just here. That means this would have to have value also. So if we had any value here, the problem is that most of these would be basically 0 value, right? Can't have all 5. You can only have 1 at most out of these 5 have value. So since only 1 of 5 could have value, it has to swap here. And again, on the borders of a grid for yin-yang shading, you can only swap twice. And we guaranteed swap here because, again, this 2 by 2 box can't have all 4 essentially have the same shading. And they would have to if this is if you don't have a boundary here. So then it would swap here, and these would be the same shading. Well, we know this has to be 2 cells which are exactly the same. Right, and this had to be shading this way, right? Because we know it could only be 2 digits at most in this box, which have the same shading. And if we don't include the center one, this 2x2 area is not going to work. So, this is all the same shading, but that means these are non-zero values, so this must be a non-zero value, and therefore you'd have a contradiction here. So what we found out is this has to be all the same shading. So, and then because, yeah, there's none of these can be basically non-shaded. What was the logic here? I'm trying to remember what the logic was here. This has to have at least four out of the 5 are do not have a value. This must be at least 2 of them must have a value. Yeah, I think it was something with this, right? Oh, these have value. So these have value. Assuming it, so both of these have value. If this has value, so say the one here swapped here, right? And if it's swapped here, so we have a similar situation, right? If we try to swap here, somewhere here, that means it swaps here to different values. So these would have to be the same shading, and therefore this would have value. So this cannot be shaded either, but it's a different shading than this. Is it? It doesn't have to be, actually. Maybe that's the error that I had. That would seem like a very weird error. So it could swap here. It could swap on the borders. So maybe that's the error? It seems a little weird. We know this is all the same shading, though. Huh. Maybe that was the bad assumption. So it could swap like here, potentially. It could technically... Okay, so... If this doesn't have... Okay. No, we know this is 1. That's how we know. This is guaranteed to be 1 because we know this has value 0. So then this must be valid, and it's a 1. So this cannot have a value here. So this is not valid. Okay, there we go. This is not valid, and these must be. And that's why it swaps there. Okay. So that's correct. Okay, so then we're going to mark these as green. And this is blue, so that goes to blue there. Which means all of these are blue. Because you can only swap twice on the edges. This is green because of the 2x2 box. Therefore, In box 7, the 0 is in the green area. In box 8, the 0 is in the green area. In box 9, the 0 is in the blue area. Box 6, the 0 is in the green area. Box 3, the 0 is in the blue area. Box 2, the 0 is in the green area. Box 1, the 0 is in the blue area. So we know this is green. We know this is a border here. Because this cannot be 1 here because of that one. So that's the reasoning there. Green has a value of 3, so this is 3. This cannot be 1 and 3 going this way. This must be 1 and 3 going that way. So this is green. This is green now here in box 2. This must be a 1-3 pair, with this being 1 and this being 3. These must both be blue to match because only the 1 and the 3 in this box work. 1 cannot be here, so 1 has to be somewhere here. 1 cannot be any of these, so 1 can't be any of these because of the 1 guaranteed here and the 1 guaranteed here in rows 4 and 5. So 1 has to be one of these 3. If the 1 is here, that means this is valid and these are invalid. And then this would be a cross of valid and invalid cells, which is not allowed. So 1 has to be one of these 2, which means these are both invalid. This cannot be 1, 9. We have a guaranteed 2. It's one of these 2. And again, if we have blue here, which is a 0 value, then you would have to have a green here, which is also 0 value, which doesn't work for that case. So this cannot be blue. This must be green, and this must be green. Since this is valid, it's a 2. And this one we don't know. This cannot be 2 here, so these must be invalid. So this must be value 0, so it's blue. Value green, so that's 0. Therefore, this must be valid value blue and 2. We know this adds up to 12 without 1 or 2. It must be a 3, 4, 5 triplet. We know 2 has to be here. So it cannot be 1, 9, or 2, 8. It's 3, 7, or 4, 6. So only one of 3 or 4 can be here. None of 3, 4, 5 can be here. So where's the other 3, 4? We have a guaranteed all 10 digits in this cage. This has to be 3, 4 here. Where is 2? 2 is one of these 4. And if it's not one of these 2, the problem is then this 2 by 2 area would be all green. So this must be green here, and one of these is a 2 guaranteed. So this cannot be 1, 9, cannot be 2, 8. It's 3, 7, or 4, 6 here. This is a 3, 4 that's not in this box, and it must be one of this one matching here. So this cannot be 3, 4 here, which makes this 6, 7. We have a guaranteed 0 cannot be here because 0 is in every box. So 0 is here, which means this can't be 0. So 0 has to be here in box 2. So 0 cannot be here, so this is 0. We can't have 0 anymore here. So 0 has to be one of these 3. This is valid. So this has a value, so that's 1. One of these is 2. This cannot be 1 and 3 because of the 1, 3 in the row. So this is only 1 is blue, 1 is green. We don't know which. One of these is 6 again. We did some interesting things here that prove that, okay, so 1 cannot be here. Okay. So this, how did we know what that is kind of the question. Hmm. This can't be 2. So this digit cannot, okay, 5 can't be here, 5 can't be here. Where's 5 in the cage? It has to be here. We know 2's already here. We know 1 out of 3 or 4 is here, and the other one is here, so this can't be 3 or 4, so this must be 6, 7, 8, or 9 here, which matches the digit that's missing from box 3. So this is A. This A must be one of these 4. So this is 1 with 6, 7, 8, 9. And these cannot be. This has to be 0, 2, 5. The other 3, 4. And you're going to have a digit that's missing. And I think it has to be 6 through 9. Right, 6 through 9. Because we are guaranteed we're not missing 3, 4, 1, 2, 3, 4, 5, or 0, obviously. So this is 6, 7, 8, 9. So I think the thing was we were able to show 6 was missing. I think it was in row 6 eventually. Okay. So we're missing 1 out of 6, 7, 8, 9 in box 6 also. Okay. Can this be 1, 2, and 3? Eight and 9 cannot be here. They can't be here. This can't be this. Right, so this cannot be 3, 4. So this is the same. This digit, so we'll make that a Z. Z and Z cannot be here. And this is a YY pair. So therefore this pair cannot add up to 10 here. So this has to be 9, 8 with 1 or 2. So one of the 8 or 9s cannot be here. This has the same problem as this one here, I think, right? If this is blue and is a 0, the problem is this would have to be green, which is 0 in value also, and that's not possible. So this cannot be blue. This is green. We have a green crosswise here, so you can't have a diagonal crosswise of blue because then these two can't be orthogonally connected without breaking up the blues. So this is green. Green is value 0, so this must be 8. Okay. This is here. We have boundary, oops. Boundary this way. Here, here. Boundary here. So, 8 cannot be here. I forget what the logic I had here was. Let's take... Okay. What happens if this is all blue? If this is all blue, then this becomes green, which means this must be blue here. This is blue, blue, so therefore this would be blue. This would be 3 blue, so that would be green here. So this would have to be valid. Green would have to go this way. So then this to be orthogonally connected. So this would be green, which means 1 would have to be here. And it would be blue. Because green has to have value of 0 because it has to go this way. Right. This would have to be an 8-9 pair. An 8-9... So this would be 2 blue. We have 3 blues there. This would be green. Cannot be 1-7. We have a guaranteed 4 here. Okay, so we have a guaranteed 4 here. It could be 1. It could be 7 here by itself, 1-6, or 2-5. It cannot be 3-4 because of the 4 that's already in the box. This could be many things actually. So this one is just basically those possibilities. So again, we try to make this 2 blues here. That forces this to be green. This is blue. This is valid. So the green has to go out somewhere here. There's a diagonal of blue here, so this must be blue. This is 2 blues, 3 blues in the 2x2 area, so this is green. Therefore, this must be a 6. This has to be a 1 because the green has to go out somewhere, and this is green, which means green has value of 0. This is blue. We must continue blue here. This can't be 1, so this would be 1. You'd have 3 and 2. So this could not be 2-5. It could not be 1-6. It would have to be 7. But then we have a blue here because this has to have a single value. Can't be 2 values with the 1, 3, and 2 there. And this would be a 2x2 area that's all blue, which is invalid. That's the reason why you can't have 3 blues here. You can't have just 0 blues because this must orthogonally connect to one of these two. So one of these is blue, one of these is green. We're not sure which. So this is 1-5 or 2-4 here. One of these two is okay. So if this is green here, this must be blue here. If this is green here, this must be blue there. Oh, this actually, we know this is a boundary. We know that's a boundary, so this has to be blue. We know this is a boundary either way. One is one of these two, the other one is value 0. So that's definitely this. That's interesting. I think we try to have this as green. If this is green, then this becomes blue and this becomes pink. Oh, they have to be different shading because of this. Because then this 2x2 area would be all blue if they were the same shading. And I think the reasoning was that this pink... Right, so basically it was without this. It was, say we had blue here, and if this is blue here, if these two are both valid, that means this is blue, this is pink, which means these cannot be the same shading as these, because then the 2x2 area would have the same shading. So this would then be green, which would force this to be... Okay, hold up. Let's also have this shading. We know these are both green, and this is a blue-green pair to be the one. So again, now we make this assumption. These two are both valid values. If we try that, these have to be different shadings. So this is green, which forces the 0 value to be blue. Well, we have two greens here. Therefore, that would force this to be green also, because you don't want the cross diagonal of the same set. You have, again, two blues here, which would force this to be blue and this not to be blue, but then this area does not connect. So that's the reasoning why these cannot be both valid. One of them's valid, one of them's invalid, which means this has to be valid here as a value. So then we know one's valid, one's invalid. This is 8 or 9. You still have the same problem, like either way. So if we try to make this green, then that means these are both non-zero, so the 0 has to be blue here. Since these are both blue, that would force this to be blue here, which means this can't be blue, that's green. This is both green here, that forces that to be green, and then we have a contradiction. So we know from that these have to be blue. So non-zero values are blue. The 0 values are green in the middle box because of that. So it's basically this relationship here. One of these, so therefore one of these is blue, the other one's green, and therefore there's a split here. So we know there's a boundary here, there's a boundary here. Okay. At least one of these is... So this is a blue-green pair, obviously. Okay. Okay. Where is this 8-9 in this cage? Cannot be here because of the 8-9 pair in the box. Can't be here. So this 8-9 has to be the 8-9 that's here. So we'll mark this as, I don't know, G. G has to be one of those two, which means this must be the other one. Where is this digit then? In... Right, because again, it cannot be here for this G, and it can't be any of these, so it must be one of these two, because we have to have all 10 digits here. So it's one of those two. So this is the other one, H. That means G cannot be here, so this must be G here. Therefore, this is green, and this cannot be green. This is blue. And this is 8, 9. So we have blue, blue here. This is blue, and this is blue. This is green. So that forces both of these to be blue. Because otherwise, you would have cross diagonals here, and then they can't form orthogonally connected regions. So these blue has to be the 0, and green must be the non-zero values. So therefore, this must be 1. This cannot be 1 here. So this goes this way. Okay, so, right. Yeah. Has to be here. Has to be boundary there. So we have 3 blues here. This cannot be blue. This is green, which forces this to be blue there. Okay. This is green. The green has to go down here, but we need a blue in this cage here. Otherwise, it's not going to have a value. So this is blue there. So this is done. This must be a 6 here, which means it cannot be 4, 6. This is a 3, 7 pair. This 3, 7 pair eliminates 3 here. So this is 4, which makes this 6. There we go. So this can't be 6 here. We're not missing 6 in box 2. We're not missing 6 in box 3 because of that, because this 6 means this has to be a different digit than all of these digits, so we need a 6 here. And we need a 6 here, because otherwise there's not going to be a 6 of it, and this is a 6 because it's a non-zero cell. So 6 cannot be here. We need a 6 in this 10 cage, and it can't be here, can't be here, so it has to be one of these two. So this can't be 6, so therefore we get the 7, 8, 9 triplet that we were talking about before. Where is H in this cage here? Can't be here. Can't be any of these, so this must be H here. So this is H and is 8 or 9. So we have an 8, 9, 8, 9 pair here. This is 3, 7. So this is matching here. So this is a 4 because 3 is here. 3 cannot be here. Remaining digits in box 2, we have 0 to 5. And then we have 3, 7, 8, 9. This can't be 3 or 7, no 3 or 7. This can't be 8 or 9, 8 or 9, no 3 here. So 3 has to be one of these two. Okay. 6 cannot be here. 6 cannot be here. 6 cannot be here. And 6 can't be any of these. We're missing 6 in box 5. And we have a 6 in column 5 and a 6 in column 6. So the 6 has to be missing from column 4. We have a 6 in row 4 and a 6 in row 5. So we're missing a 6 in row 6 here. That means this cannot be 8 and 9. We have to have 8, 9 pair in... We have to have an 8, 9 pair in row 6. Cannot be here because of the 8, 9 pair in the box. Can't be here because these are filled out. with other things, so it has to be here. And because of this 8-9 pair, you can't have... Even if this were 9 and green, the problem is you would have to have an 8 here, and that 9 would eliminate 9 here. So this must be 8 here, and it must be blue, which makes this green. That means this can't be 8. This is 9, which forces this to be 9. This is 8. 8 matches there. So this is 9 and 1. This is 8. This must be a 9 in one of these two spots. This must be 1, 5, and 2, 4, adding up to 6. This is 8 and 9 there. We have 3 blues here, so this cannot be blue. This is green. This is green, so 8 cannot be either of these. So that's how we got... 8 cannot be in A. Or sorry, 8 has to be in A. 8's not the missing digit in A. So since 4 cannot be here or here, 4 has to be one of these two, which eliminates 4 in the rest of the row. So 4 in box 1 has to be here, and it has to be non-zero. So this is not blue, this is green, which means this can't be green, this is blue. And can this ever be the same or non-zero values in both of them? And the answer is, I think, no. If it is, this would be green, and then this would be blue to be non-zero. And that's not possible because you'd have a cross green and a cross blue here. So this has to have a 5. This can't be 5 or 4, it's 3. So this is 3 here, because one of these is a 5. And it's either both blues or both greens. Remaining digits in row 6 are 3, 4, 5, 7. So the 8, we have all the digits in this cage, right? The 8 has to be here. That means these 3 digits must be essentially here and these two. We had, okay, so this was not 9. So we have, this can't be, this is 0, 1, 5, no 8, and no 2. So we know 2 has to be, okay, 2 can't be any of these. We know there's a split here. So this becomes a blue-green pair. Well, we already knew that. I think we tried what happens if they're both green, right? This can't be 5 because one of these two is 5 here. I think we tried if 5 was here. So, did we? That means these are both blue. Maybe we tried if both are green. Actually, I think it was one of these that we tried. Okay, so we know this is boundary. So in the rest of the boxes, we're missing 1 through 5. These... Actually, I guess it could be these 3 cells. We could be missing a 1 here. Remaining digits in box 4. 0, 2, 3, 4, 5, 7. This can't be 3, 4, and this can't be 3, 4, or 5. So where's 6 in this cage here? It has to be one of these two. This 027 sees all of these and all of these, so this must be here. So this is 6027 here. We're not missing 2 and 3 in box 9. We're not missing 1 in box 8. We're not missing 4 in box 1. We're not missing 1 in box 4. Remaining digits in... Okay, so this is, again, 0, 2, 3, 4, 5, 7. No 4 here, no 4 here, no 4 here, so this can't be 2 here. Okay. Remaining digits in box 5. We have to have 0, no 1, 2, 3, 5, no 6, 7. 0, 2, 3, 5, 7. Okay. This can't be 3 because of 3 in the row. Remaining digits in box 8. 0 cannot be here, therefore 0 is either here or here. This cell... Oh. No. These are the same cage. Oh, maybe that was the bad assumption here. Interesting. These 4 cells have to... 3 of them have to be here, and the other one is the missing digit here. Okay. So this cannot be this. It can be any of these. So it could be 0, 1, not 2, or 3, 5, 7 here. Okay. Yeah, 0 could still be here. Remaining digits in box 8. We have 0, 2, 3, 4, 5, 7. And this can't be 2. This can't be 4. This can't be 3. So 4 has to be one of these two here. So these 3 digits, again, must match these. And these 4 match these 3 and the one that's missing in box 7. Remaining digit here. Okay, so these 2. This could be 0, 2, 0, 2, no 1, 3, 4, 5, no 6, 7. Oops. 0, 1, 2. No 3, 4, 5, no 6, 7, 8, no 1. So this digit can be 0, 1, no 0, because we have a 0 in the cage. 1, no 2, no 3, no 4, 5, no 6. It could be 7. This is 1, 7, or 9 here. We have a guaranteed 0 here. Think we tried essentially making one of these blue and then the other one green. And that was where we were solving things. This is guaranteed 4. Six is one of these two. What are the remaining digits in row? Okay, so this is 6. If I remember correctly, this had to be blue. So what happens if we assume it's green? Was that the assumption that we made? I don't think that was the assumption we made. It was that one had to be. We tried to make one of these, and then that made some problems. I don't remember which one it was. Was it this one? We had one. No, it was the other one, I think. If we try to have one here, then this is blue, which makes this not blue, so this is green. Therefore, this is not 1, that's 0, which makes this 1. So then this becomes blue, and this is not blue, so it's green. This is 3 greens, so therefore this cannot be green, that's blue, which means that can't be blue, that's green. This does not have a 0, then. No 0, no 0, so where is the 0? It has to be here. In box 5, that eliminates 0 from the rest of the cage, so 0 has to be here, which means this can't be 0, so 0 is there. So far this is looking okay. 0 is one of these two. This can't be 0. No 0 here. Maybe we made the assumption that was a 5. I don't know. This then becomes a 2. This is not a 2 or 0, it's 5 or 8. Three is one of these two. This becomes a 2, 5, 7 triplet, which eliminates 2, 5. This has to be 6. This cannot be 1. We have a 7, 8, 9 triplet, which eliminates 7, 8, 9 in the rest of the row. So no 7 here. This is looking actually okay. Was this the assumption that I made? I don't remember. This must go out, so then this must be green, green. So this is green, which means it can't be 5. So 5 has to be here. So we're missing... I think this is actually valid? This cannot be 5 here. Where's the 5 in box? Yeah, maybe this is valid. Box 5. That would force this not to be 5. This is a 3, 7 pair, which eliminates 3, 7 here, so this is 4. We don't have a 2 here, so then this cannot be, this has to have 2 here, therefore this is a 1, 5 pair here. But we have a contradiction, because we don't have a 5 here, we don't have a 5 here. And there's no 5 in this cage then, which we have to have. So that's the contradiction. And that was assuming, yeah, 1 there. So then we have, I don't even know how we did that. Anyways, this is 1. Can't be green. This is not. So this can't be 1 here. Maybe this was the bad assumption here. Anyways, this has to be 1. This is not green. This is blue. So this is not blue. This is green. So we have boundary this way. Boundary here. This cannot be 1. These are boundaries here. This is boundary here. What happened? What happens if we make that green assumption? It's green. This has 0 value, and this is a 5 then. So this is 5. That would mean this is not 5 here. This can't be 5. One of these two is 5. So this can't be 5. This would be 4. This would be 5. So no 5 here. Obviously no 5 here. We have a 3 7 3 7 pair in row 6, which eliminates 3 7 in the rest of the row. This is 4, so this cannot be 4 here. No 4 and 2. This would be a 1 5 pair, which eliminates 1 and 5 in the rest of the box and row. Those can't be 1 there. We are not missing, we are missing a 2 in box, well, in this cell here. And this 1 5, we have a problem with 1 5 trying to match here. And it can't, because 5 is here. So that's why it cannot be green. So then we have both of them being blue. And again, it cannot be 1 green and 1 blue, because then you have the cross diagonal thing where you can't orthogonally connect the two yin-yang regions. So this is boundary, this is boundary, this is boundary, this must connect to green. This is blue and blue, so this is non-zero, so this is 5, which means this can't be 5 here. We're guaranteed a 6 here. This 5 eliminates 5 here, so this is 0, which means this can't be 0. So we have to have a 0 in this cage here, so this can't be 0 here. So no 0 here, no 0 here. This can't be 0 then. We're missing a 5 or 8 in column 5. This can't be 5. We have a 2 3 7 triplet, which means this must be 2 here, so this cannot be 2. This again matches these 4 cells must match these cells and this. If we try to have 2 and 4, this can't be 2 and 4. So this must be a 1 5 pair, which eliminates 1 and 5 in the rest of the box. We have a 3 7 pair here, a 3 7 pair here. This can't be 5. No 5 here, no 5 here. This is a 3 7 3 7 pair. So this one matches one of these two. Therefore, there must be a 5 here somewhere. So there's a guaranteed 5 here. So it's not missing a 5 here. There's a guaranteed 1 and 5 here. We are missing a 2 in this cage, so 2 cannot be missing here. Okay. This has to add up to 7. It cannot, it's 1, 5, 1, 6, or 2, 5. Which means this is 1, 6, or 2, 5 here. So this cannot be 5 here. Which means this is 5 here. So this can't be 5 here. This is 1, this is 5. That eliminates 2, 5 here, so this is 1 and 6. This can't be 6. So 6 has to be here. Okay, we have to have a 9 here somewhere. So we're missing 3 or 4 here. Okay. So 6 cannot be here. 6 is one of these 3. Okay, remaining digits. Okay, 1 eliminates 1 here. So what we're missing could be 2. No 1, 3. No 4, 5, 7, 8, 9. This could be 2, 3, 5, 7, 8, 9. And so we have all three. This can't be 1. So we're missing a 1 in box 9. We're missing a 1 in row 7. We're missing, so 2, no 1, no 3, 4, 7, 9. That's possibilities. And this is 2, 3, 5, 2, 3, 4, 5, 7 here. This is 2, 6, 7, 8, 9. Cannot be 6 because of the 6 already here. We're missing 4, 5, 7, 8, 9. We're missing 4, 5, 6, 7, 9. No 6. We're missing 2, 3, 5, 7, 9. We're missing 2, 3, 5, 7, 9. Here we're missing 2, 3, 4, and 7. Okay. Remaining digits in row 8. Could be 0, no 1, no 2, no 3, 4, 5, 6, or 9. This can't be 6 because of 6 in the row column. 0, 4, 5, 6, 9. 0, 4, 5, 6, 9. This can't be 4 or 5. This can't be 0 because one of these, that would be 0 in this cage. Yeah, I think I just made a bad assumption in one of these cages. Remaining, okay, 6, okay, yeah. Remaining digits in column 2. Could be 0, no 1, 2, 3, no 4, no 5, 6, 7. So those are the possibilities. This is 2, 3, 5, 7, 8, 9. Because 4 has to be one of these two. This is 2, 3, 4, 5, 7, 8, 9. No 5s, though. Right, because one of these is 5 and one of these is 5. Yeah, I think I had a 4 there. That's weird. Huh. Yeah, I don't know. I'm not sure how I did that. Weird. Okay. So that was the problem with that. I don't know what's missing here. Okay. One cannot be here. We're missing a 1 in column 9. And it must be related to the 1 there. That means these cannot be 4 or 5 we're missing in column 7 or 8 because we're missing only a 7, 9 and a 7, 8, 9 remaining in those boxes. This has to be 2, 3, 4, 5, 7, 8, 9 as possibilities. It can't be 7, 8, 9. No 7, no 7 or 9 here for these cells. Okay. Yeah, I think I had a bad deletion here somewhere. I'm not sure how, but I did. Yeah. Okay. Zero has to be one of these two. Zero is one of these four. Remaining digits in row 9. We have 0, 2, 3, 4, 5, 7. 0, 2, 3, 4, 5, 7. No 2, 3 here. No 0 here. No 0 here. So 4, 5, and 7 here. No 0, 1, 2, 3, 6, 8, or 9. No 0. No 1, no 2, no 3, 4, 5, 6. Okay, this has to be 7. Okay. This can't be 0 or 2 or 1 or 3 or 4 or 5 or 6, 8, and 9. So this has to be 7 here, which makes this 9, which makes that 6. So this cannot be 7 here. We're not missing 7 there then. Oh, you're not missing 7 or 9 here. This is 2 or 4. No 7 here, no 7 here, no 7 here. This 0, 2 matches the 0, 2 here. No 6 or 9 here. So this can't be 6, which means 6 cannot be here. Remaining digits of column 9 are 0, 2, and 8. So this is 0, 2, 8. This becomes a 4, 6 pair. Those are the only places 4 and 6 can be, and they have to be there. Therefore, the remaining digit is 5 with a 7 or 9. We're not sure which. So this cannot be missing a 5 here. Okay. We know we have a guaranteed 2 somewhere here. This 0 is missing the 7, 8, and 9 that's in box 6. This has to be A, right? Because if it's not A, that means it's missing the one from box 6 twice, which is not allowed. So this must be matching A. Because if it's not matching A, again, which means A cannot be here. So A has to be here. So this must be A here. Interesting logic. Right, because this is missing a 7, 8, 9, but if it's missing it cannot be missing the same one as the one in the box, so it must be missing A in the column. So A cannot be here, A has to be here, this must be 6. And this is the one that's missing for this cell. But, right, so this must match here. So this has to be a 7, 9 pair, which means 8 has to be somewhere in box 2. So this has to be 8, which means, and we can't have 7 or 9 here, which means this is 8, so this cannot be 8. This is 5. This is a 2, 8 pair, which eliminates 2 and 8. Therefore, this is a 5 we're missing. So 5 cannot be here, 5 cannot be here. This can't be 5. So we have to have, we're missing a 5 here. So this cannot be 5. This is 0, this is 4. This is 0, 4 there, so this is 5, this is 4, that's 0. This can't be 0, 4, 5, so this is 9. No 9 here. No 5 here because of the 5 in the box. The 5 has to be one of these. 0 eliminates 0 here, so this is 2. No 0, 2, or 4, so that's 3, which makes this 7. So this must be 2 here. This must be 0 here. This can't be, this has to be 0 here. So this becomes a 2, 7 pair. 7 eliminates 7 here, so this is 3, which makes this 7. This can no longer be 7 here. This is a 2, 3 pair. So this is missing an 8. Hold up, that's not right. That is not right. That's not right. That's not right. That's not right. That logic was not good. This logic is still sound, I think. A, so that has to be 6. How? We're missing 7, 8, or 9. This has to be missing A. Which means in column... Yes, okay, that's correct. In column... column 7, we're missing another 7, 9. Which means we're missing a 7, 9 pair in box 6 and box 3. This is the A7, 9, so this can't be 7, 9 here. It's 5. Which eliminates 5 here. This is obviously the non-A7, 9. So 5. We're missing, this has to be the... This has to be 8. Because we're missing the other 7, 9. Well, it can't be here, so this must be 8. Okay, so that 8 eliminates 8 here, so this is 9, which makes this 8. Okay, that's good. Okay, so that was bad logic previously, but now we're good. Okay, so this can't be 8. Therefore, this is a 2-5 pair, which means we're missing 8 here. And yeah, that means we're missing 8 up there. Okay, that's correct. So we cannot be having a 5 in the rest of box 2. There we go. We're missing 8 here, so therefore we have a 2-5 pair there. Or it's the other way around. Maybe we have a 2-5 pair there, so we're missing 8. Yeah, we have a 2-5 pair there, so we're missing 8. Because 8 cannot be here in the cage, because we need to have an 8 here. Because we're missing the 7-9 in... That's missing in column 7 in box 6. So no 5. This becomes a 0-4 pair, which eliminates 0-4 in the rest of the column. This can't be 4. That's 6, which makes this 4. That can't be 4. That's 5. Okay. So... Huh. So 8 has to be one of these 3 that we're missing. So it can't be missing... Or we could be missing 7, 9. 8 cannot be missing here. This can't be missing 2 because of the 2 in the row. So this can't... Oh yeah, this is a 7, 9 pair. Eliminate 7, 9 in the rest of the column. Therefore, 9 has to be one of these 2 here. This can't be 9 that we're missing here. This can't be 5 in box 7. We have a 0-4 pair in row 7, which eliminates 0-4 in the rest of the row. This can't be 0. This is 5. This can't be 0-4, so it's 9. Yeah, we can't have that being 9. We don't know what's missing here. Okay. If this were missing a 2 here, that means... That's possible. Never mind. Okay. 3 is one of these 2. We're not missing a 5. Okay, so we're not missing a 5 in box 8. Because this has to be a 5 here. Therefore, we're missing a 5 in box 1. Okay. So 5 has to be one of these 2. This cannot be 5. Oh, it could be 5 anyways. Okay. Remaining digits in column in box 1 are 0, 2, 3, 7, 8, 9. Okay. No 9 here. So 9 is one of these 2. Okay. This can't be 5. We have to have a 5 here, so this can't be missing 5. So column 1 must be missing the 5. We have column 3 and 6 missing 2 and 3, so column 4 2 must be missing the 4. So this cannot have a 4 here. But you have a 3, 7, 3, 7 pair, which eliminates 3, 7 in the rest of the column. This is 3, 5, and 7 in this cage, which eliminates 3 and 7 in the rest of the box. In box 7, we have 0, 2, and 4, so this cannot be 4. We're missing a 3. So this can't be missing 3. This is not missing 3. It's 2 or 4. This is 2 or 4. So this can't be 3. This must be 7, which makes this 3. Which makes this 7, which makes that 3, 7. 3 and 7 eliminate 3 and 7 here, so it's 5. This can't be 3 or 5, so it's 7. Which means this cannot be 7. This is a 0, 2 pair, which means we're missing 4 in that box. So this is missing 4, and this is missing 2. So this cannot be missing 2. This is missing a 7 or 9. Therefore, we must be missing 4 here. We must be missing 2 here. And we must be missing 3 here. No 2 or 3, no 2, no 2 or 3. This can't be 2. No 2 here. If there was a 0 in either of these spots, it would be missing a 2 in the row and in the box, which is not allowed. So this cannot be 0, therefore this is 7. This can't be 0, so this is 4, which makes this 0. That 4 eliminates 4 here, so this is 0, 2, and 4. 2 eliminates 2 in the rest of the column, so this is 0. That eliminates 0 the rest of the box. This 0 here makes that not 0, so this is 2, which makes this 0. These cannot be 7 anymore. This 5 eliminates 5 here, so this is 4, which makes this 5. This cannot be 7 or 8. No 7 or 8 here, no 2 here. We have a 3, 7, 8 triplet, which eliminates 3, 7, 8 in the rest of column, or box 1. So this is a 2, 9 pair, which eliminates 2 and 9 in the rest of the column. So this we're missing a 3 here, and we're missing a 2 here. So since we're missing a 2 here, this cannot be 2. This is 3, which makes this 2. 0 eliminates 0 here, so this is 7, not 0 or 7. This is 3. This 7 eliminates 7 here, so it's 9. Which means we're missing 9 in box 3. We're missing 7 in box 6. So this must be a 9 here. No 3, 7, or 9. It's 0. 3 eliminates... This can't be 3 or 7. It's 8. This can't be 3 or 8. So this is 7, which makes this a 3. That's 3 in the corner. We celebrate because we know we're close to solving it. There's no 0 here. We are not missing 7, 8, or 9 here, so we must be missing 5. So therefore this cannot be 5. This is 2, that's 5. This can't be 2 or 8, so it's 0. No 5 here. We're missing 7 here. And this must be 8 or 9 we're missing. This is 2. So this is blue here to be that non-zero. And this is green here. So we're done with the shading. We are missing a non-9 here, so 7, and this is 9. This 0 sees a 2, and is missing 8. So cannot be missing 8 here, so it must be missing 9, which makes this is not missing 8. 9 means we're missing 9 here, so this is 2 and 9. 2 eliminates 2 here, so it's 8 and 2. This can't be 9, this is 7. And this can't be 0, it's 4, which makes this 0. Uh-oh. This 0 is missing 8, 4, and 5. This 0 is missing 2, 8, and 9. This 0 is missing 5, 9, and 1. This 0 is missing 7, 4, and 3. This 0 is missing 4, 6, and 8. This 0 is missing 6, 9, and 7. This 0 is missing 5, 2, and 3. This 0 is missing 6, 1, and 2. And this 0 is missing 3, 7, and 1. Okay. In the cages, these are value 0. This doesn't match the 0, so this is value 1. This doesn't match 0, and it's value 10. These match 0, and 1 and 3 plus this matches 0, so that's 4. 2 matches 0, so 4 is there. 1 and 6 don't match 0, that's 7. These match 0, so we have 2. We have the final boundary here, too. So that's 2. This matches 0. These match 0. So that's 2 and 1 add up to 3. Doesn't match 0, so 1. This is 0. This doesn't match the 0. This does, so that's 5. 8 and 9 doesn't match 0. 17 doesn't match 0. 6 does match 0. Matches 0 here. Doesn't match 0. So that's 1. Matches 0. Matches 0. So that's 1. Matches 0 plus 5 and 1 is 6. Doesn't match 0. 8 is 0. Doesn't match 0. It's 9. That's 17. 7 doesn't match 0. 3 doesn't match 0. That's 10. 1 and 9 don't match 0. That's 10. Matches 0. 6 doesn't match 0. Matches 0 and doesn't match 0. So that's 8. 0 matches. Doesn't match. It's 3. That's a 0. Match 0 plus 2 is 2. Match 0, match 0, and this doesn't match 0, that's 2. 3, 4, 5 adds up to 12. And match 0 plus 8 doesn't match 0 is 8. So all the cages are done. Yeah, I think this is the solution. It didn't solve, though, which is why it doesn't have any solves in the actual... Like, if you take a look, if you pause... Oh, the puzzle does not have solution checking. Okay. So you can't actually solve it, quote-unquote. But this is the solution here. Huh. Wow, that was another full hour afterwards to solve this. Interesting. Very cool, actually. Very, very nice puzzle. Even when, like, I even saw my mistakes. So, that was good, I guess. Anyways, I hope you enjoyed these solves, and I'll see you next time on Frank Puzzles. Take care.